Move on, and we're going to learn about the area of certain parallelograms. The way I'd like to start off today is I'd like you guys to take out your graph paper, and I'd like you guys to draw a few different rectangles for me with the following dimensions. The first one I'd like you to draw, I would like to be 4 units this way, and 6 units this way. And usually, I would have a smart board. Second rectangle, we'll have 3 units here, 7 units here. And a third rectangle, we'll do 4 units by 5 units. Now, yesterday in class we learned about the perimeter. Can anyone raise their hand and tell me what the general idea of perimeter means? Kara?
Measuring the outside, total outside.
Yeah, the outside, the distance around. So yesterday we were working with, if I walked around this rectangle, how far did I go? That would be the perimeter. Today we're going to work with the inside, the area of the inside, and how many square units we have inside these rectangles. So if you take a look at the first rectangle you drew, how many square units are there in that rectangle that you drew? Anyone raise their hand and tell me? Yeah?
24.
Sure. Inside here, we would have 24 of those square units. And right now I'm using the word units. Those units could be replaced by feet, by miles, by inches, anything of that measure. This next rectangle here, the rectangle that's 7 by 3, if we counted the amount of square units inside of here, how many units would you count? Yes?
21.
Sure. We would have 21 of those square units. And finally, if we take a look at this rectangle here, how many square units would we have inside here? Marissa?
20.
Sure. We would have 20 square units. Now, if we take a look at these 3 rectangles, we're going to see if you guys can come up with a formula for the area of a rectangle on your own. So if we take a look at the 6 and the 4 here, and we end up with 24, what did we do with those 2 numbers? Mark?
We multiply them.
Sure, we multiply them. I'm going to call this my base, and I'm going to call this my height. So I multiply the number of units on the base by the number of units on the height. This next rectangle here, I have 7 and 3. So here I'll just multiply the base by the height. So all our formula for the area of a rectangle is the formula for the area of a rectangle will just be area is equal to the base multiplied by the height. And all that formula really is a shortcut to find out how many of those small square units you have inside the larger rectangle. Now if you go home tonight and you take a look at your bathroom floor, your kitchen floor, if you have tiles, you'll probably notice if you measured them, they're measured in a certain way. They might be 1 foot by 1 foot, or 1 centimeter by 1 centimeter. The reason they do that is to make it easy. So if I found the area of this room, and I found out that it was, say, 300 square feet, I would know exactly how many of those square tiles I would need to tile my kitchen. Or if I had a small bathroom and I found out that it was 150 square inches, I could drive down to Home Depot, square feet. Sorry. I could just do a quick conversion and find out how many of those small 1 inch by 1 inch tiles I would need to cover my bathroom floor. So what we're going to do today is we're going to kind of take a look at an open response. You guys are going to be kind of landscapers for the day. So we'll kind of do the first parts of this problem together, and then you guys can break into groups and do the last couple parts together. So part A, first off, below is a diagram of a backyard. It's a square that has side lengths of 20 feet. So this backyard, it's a nice square. We'll keep it nice and simple. And we'll say it's 20 feet by 20 feet. Now from what we learned yesterday, who could answer part A? What would the perimeter of this backyard be? So if I wanted to put up a fence here, how much fencing would I need? Mark?
80 feet.
Sure, I would need 80 feet. Of fencing. Notice I didn't answer my perimeter question in square feet. Because I don't have to know how many squares I need. I just have to know the distance around this backyard. Second, what would the area in square feet be of the backyard? You want to use the formula that we came up with, area equals base times height, to find out the area of the backyard. If you know the answer, you may raise your hand. Give you a little help. What would the base of the backyard be? 20, sure. And the height? 2 times 2 is 4 with 2 zeros. So I would say that the area of this backyard would be 400 square feet. So that would mean in this backyard, I could fit 400 feet that were 1 foot by 1 foot. I could fit 400 of those squares. Now I'm sure many of you guys see me working at Cunningham Park over the summer doing the landscaping and mowing the lawns, and they think I'm some sort of math genius because I know how much fertilizer to buy for a certain area. And all I'm doing is I'm just doing the base and the height of a certain field. And I tell them how many bags they have to buy, and they think I'm some sort of whiz. Or I'll come out, they'll ask me how much mulch we need for a circular path, and I can find the radius of it, and I say we need this many yards of mulch. It's just simple math, but it can really save you money and time and water. So part C says we're going to assume the role of a landscaper, and we're hired to do some work in the backyard. The homeowner wants a garden with an area of 48 square feet. Now this is a little bit different than what we were doing before. Part C is asking us to construct as many gardens as you can with an area of 48 square feet that would adequately fit the backyard. What would the dimensions of the garden be? Now notice that this backyard is 20 feet by 20 feet. And I want to make a rectangular garden that's 48 square feet that can fit in here. I'll give you guys a hint. I am not going to make a rectangular garden that is 1 foot by 48 feet. So then you would have some angry neighbors. But what we want to do now is we want to come up with some rectangular gardens that have an area of 48 square feet that could fit in this backyard. You guys may work together and come up with some of those.
You're going to have to do that.
400. I don't know. See, that's what I got.
Well, no, actually, I would say 2,
Right.
They don't have to be square. They can be rectangles. It has to be 48 square
Can
feet.
it be like
No rectangles.
So what times what is 48?
6 by 8.
2 by what? 2 by 20.
1 by 48 is what?
Very good.
2 by 4 still doesn't work. 3 by 16. 4 by 20.
Right off the page, absolutely.
Yeah, you can do it unless you go into like half.
I didn't know they fit in the 20 by 20.
Okay. Let's take a look at some of the dimensions that we came up with. You can raise the hand and tell me the size of a garden that they could use. Yes, go ahead.
4 by 12.
Sure. We could have a garden that's 4 feet by 12 feet. How about another size? Yes?
6 by 8.
Sure. 6 feet by 8 feet. How about one more?
3 by 16.
Sure. Let's see who can be my star of the day. 4, 12, 6, 8, 3, and 16 are blank of 48. Yeah.
Roots?
Nope.
Square roots?
No.
Factors.
Factors, right.
Oh.
The fact is the 48. These are all factors, 48.
No.
So these are all possible sizes of gardens that we could fit in our backyard.